Now, the gravity methods are often used in the detection of underground cavities and caves. Buried cavities due to old mine workings can be very hazardous, right? Very ancient mines, right? Several hundred years ago, people would have mined under the ground, and today we may not know whether such a mine exists below us or not, right? So, cavities are determined very easily because they can be a good target for gravity surveying. Why? Because cavities are going to have only air. Sometimes cavities are filled with some loose material, right? So, compared to the surrounding rocks, cavities are having lesser density, right? Imagine there is a big cavity here, cave, right? The density of the cave is less because it is going to be filled with air. The rocks around that will have high density, right? So, when you do gravity profiling over there, what you can expect? Gravity value will be lower just above the cave, right? So, we will be able to distinguish such cavities. In fact, such cavities and caves are a potential hazard in several parts of the world, right? Very big buildings have suddenly got caved in because of the presence of limestone caves. Many instances in America, right, where you have very huge limestone deposits on the west coast of America, right. So, these limestones are capable of dissolving in groundwater. So, they eventually large amount of limestone would have got dissolved, leading to formation of huge caves. These caves can be detected by gravity methods, right. Usually, many anomalies are greater than predicted by the theory, right. So, that is what I said, we cannot have a unique solution, right. Measured anomaly will be usually expected to be greater than the theoretically estimated anomaly. So, we have to be very careful, right. So, gravity methods are one of the simplest method to detect cavities, right. Suppose if you are working on a limestone terrain, if it is a limestone formation, caves are expected. Over there, if you want to do any development, right, we need to make sure there is not going to be any disaster in future. Like what disaster? Sudden caving, right. Over there, if you develop, if you want to plan a major building, the whole area may cave in, right. The roof will collapse, right. To know the location of caves, we can deploy gravity methods. And here, right, gravity anomalies of long cylinders has been theoretically estimated, right, with respect to its depth of location as well as its size in the sense diameter, right. So, why I am showing this is we can theoretically compute the anomaly. With this theoretically computed anomaly, we can compare the anomaly which we have got from our survey. If both of them are matching, right, what we can conclude? We can conclude at the unknown site a cylinder is expected whose dimension is equivalent to that of B here. Okay. So, let us have a look into this picture now, which much more carefully. Here we have assumed a cylinder of diameter, as you can see here, a large cylinder of diameter of about 12 meters is located at this depth from the surface at 18 meters. When it is at 18 meters, the expected profile which you will get, it is a cross section, right. So, when you walk from here to here with a gravimeter, you made the measurements of gravity. Gravity anomaly is this, right. Now, if the same cylinder is somewhere here C, then this is C. For B, for A small cylinder very close to the surface of the earth. Please see here, right, the magnitude of the anomaly which we measure depend on the size of the object as well as its depth of burial, right. Cylinder A is very small, only about 1.5 to 2 meters, but it gave a strong signal. Why? Cylinder A is located at 2-3 meters below the surface of the earth. That is why we have got the highest anomaly, right. If you take cylinder D, which is very big compared to cylinder A, nearly about 12 meter in diameter, but the anomaly which we have measured at the surface is comparatively lesser. Why? Because of the depth of burial. So, to show you that I am using this cross section of this agency, Environmental Protection Agency of United States of America, right. So, this picture helps us to understand what is the expected gravity anomaly, how the gravity anomaly is related to the depth and size, right, and also distance from the peak, right. So, look at the distance from the peak. So, this is the peak anomaly. Since the cylinder's diameter is very small, very quickly we go to the background value. Take a look at D. D is a very large cylinder, so it is a maximum peak, maximum anomaly. For the anomaly to become almost 0, it takes a lot of distance, right. So, the gravity anomaly depend on the depth at which the expected anomalous body is present and also its size. Okay. Here is another interesting case study carried out by this group of people, right, and their work is published in this journal. What they have done here is they had used gravity measurements to explore for groundwater in crystalline rocks, right, in Hyderabad, right. So, what they have done is they carried out gravity survey in the university campus, Osmania University in Hyderabad, which is located over the granitic rocks, especially southern India. Most of southern India is made up of granitic rocks. Here in the granite, we have a potential aquifer in the weathered formation, right. What is weathered formation? Rocks are very much disintegrated, right. So, below at the surface, this is the ground surface, rocks are very much weathered, and below you may have massive rocks. Here it is weathered, right, weathered rock and massive rocks, right. So, what happens is in the weathered zone, as well as if the rocks are fractured up to some distance, it is fractured. Beyond that, you have massive. This is fractured, this is completely weathered, right. So, as the rocks are fractured and weathered, the porosity of the rocks increase, isn't it? It is quite obvious. When the rocks are intact, it doesn't have any pores. The porosity is a measure of volume of voids to the total volume. It is a ratio of volume of voids to the total volume. So, porosity will increase if the rocks are very much dissected, fractured and weathered. Okay. When they are fractured and weathered, its bulk density will decrease, right. Bulk density will decrease. So, the changes in the bulk density of the rocks lead to gravity anomaly in the range of 0.1 to 0.7 milligauge, right, at this particular site. So, this variation can be detected using the gravity survey, right. So, gravity survey over their campus, right, at this site, the gravity variations helped us to understand about the subsurface formation as well as the thickness of the weathered zone, right. That is what they have done and reported in this journal, hydrogeology journal, right. The anomalies also help us to define the position of intrusives. What is intrusives? Intrusives are the rocks which intrude into the already formed rock. This is the ground surface, you have some rocks everywhere, right. Within that, from the bottom, a intrusion can take place. This is what we call it as dike, right. So, the intrusives can be delineated by them, right, using the gravity survey, and they have also delineated lineaments. Lineaments are linear features. Linear features are usually weak fractures, joints, faults. They are all called as lineaments. So, the gravity survey helped them to identify intrusives as well as lineaments. Not only that, they have also found out areas where we have deeply weathered granite, that means highly weathered granites, right. In such regions, the university had wells that yield high groundwater, right. That means there is a one-to-one relationship between thickness of weathering as well as gravity measurements and the well yield, right. That means wherever you had negative gravity measurements compared to the base value. What do we mean by negative? This is the profile. There is a base value is somewhere here. When compared to that, the values are decreasing, going to the same, going down, going. So, all these are all negative values, negative locations, isn't it? So, areas which are deeply weathered or highly weathered granite, right, has very low gravity values, negative gravity values. In such regions, they had wells that yield large amount of groundwater. So, this is what they have done in their study. So, in weathered zone, well yields has got inverse relationship to the magnitude of residual gravity, right. So, the gravity values are very less at the same location, well yield is high. There is an inverse relationship between well yield and the gravity value. So, this is how this case study help us to understand about the groundwater fluctuation using gravity survey. Many researchers have deployed ground-based gravity survey to understand the water balance. Because when the water table is higher, when the groundwater table is higher over there, we are expected to have higher acceleration due to gravity. When the water table goes down, let us say water table has gone down by 50 meters, so much is the reduction in the mass over there, right? That reduces the acceleration due to gravity. So, here is one example carried out by our friends from Osmania University. Right? And we can also understand the presence of fault. Fault is a major structure below the surface of the earth where the blocks of earth has relatively moved past over one another. That means here if this is a formation, right, this formation has moved upwards and which is not there on the right hand side, then there is a next formation. This formation has moved somewhere here. Then we had the third formation. This formation has moved comparatively as indicated by the arrows. This block of earth has moved over the top, this has moved downwards. So, this rupture plane in between is known as fault. The rupture plane in between is known as a fault. The fault can also be located by gravity survey. So, here you can see the presence of a fault. Right here, the blocks of earth has moved past each other. Right? There was a relative movement, something like shear. Right? Over there, gravity survey has been carried out. The gravity anomaly has been picked up, right, and inverse modeling has been done, right, by assuming what is the gravity effect of the horizontal cylinder which got separated as you see in the diagram due to the relative movement, right. By assuming different thicknesses and different angle of inclination of the fault plane, right, we can create the expected gravity anomaly which we can measure at the surface, right. Using this, we can try to locate the presence of fault below the surface of the earth. That means, it is a inverse modeling work using which we can determine the location of the fault below the surface of the earth. What are all the various other applications? Right. There are several applications of gravity survey. In fact, never we will commence oil exploration without doing gravity survey. So, gravity survey is almost indispensable for oil exploration, that is hydrocarbon exploration, and very much it is used in mineral exploration too, especially when the density contrast between the mineral which we are searching and the ambient formation is higher, both positive as well as on the negative side. For example, you are searching for a ore of a particular mineral, maybe galena, which is very dense, right, or for example, if you are searching for a pure gold, gold has got very high specific gravity and density, nearly 19, right, 19 grams per cc, right. So, which is very high. So, when you search for such dense formation or light formation, we can rely on gravity survey. You are searching for a mineral which is very dense, maybe you are searching for native gold, then we can depend on gravity survey. And gravity survey is also today, gravity methods are used since last 20 years. We are very much using that to understand the climate change impacts on groundwater or on water, how the global water mass changes due to climate effects. To understand this also, we can make use of gravity methods. And gravity survey is very much used in basic geophysical research, especially to understand crustal motion. As I had told you initially, right, to understand the crustal motion or movement of plates on the surface of the earth. That means the earth's surface is made up of different plates consisting of some continents. As I told you, Indian plate is colliding with the Euro-Asian plate just north of Himalaya, that is Tibet, right. So, to understand that also we can rely on gravity methods to understand the geoid volcanic eruption monitoring. We had seen right at the beginning, right, when the rock begins to melt below the surface of the earth, right, this is a chamber, magmatic chamber. When the magma begins to melt, what will happen to the gravity? Suppose you are measuring the gravity value here. Now, magma is much denser than the surrounding rock. So, your gravity profile will be like this. When this is the ground surface. When the magma begins to melt, right, it is going to erupt as a volcano. When it begins to melt, the gravity value will decrease, isn't it? So, in monitoring volcanic eruption, also we can use gravity survey. Gravity methods are also used in earthquake prediction as well as earthquake research, right. And also the impact of tidal variation of the earth surface, right, over a long period of time is also being monitored, and we are also trying to attempt inverse modeling to understand how the tidal effects will change the earth surface in future, can also be done. Then of course, the best application is in environmental monitoring. As I told you, how fast our groundwater resources are depleting, right, can be studied using gravity measurements. Whether the landfill is located here, whether there is a buried, abandoned, old landfill can be discriminated from the surrounding native rocks. How landfills will have comparatively less density material than the native formation, right. And gravity methods are also used to understand sea level variations and also melting ice mass in the polar region can also be picked up from the gravity measurements. As the sea level rises, gravitational pull or acceleration due to gravity will also increase, because for every centimeter rise in sea is addition of mass over the water surface, isn't it? So, these are all the various applications of gravity methods. So, in this lecture today, we continued with how we can carry on with the interpretation of gravity data. We had seen initially direct interpretation, then we had seen indirect interpretation of gravity data, which is known as inverse modeling. Toward the end, we have seen some applications. In the next lecture, we will continue with some typical case studies. Thank you very much.